Hi, I'm Maxime, a French engineer. Here's my face, and here's the face of my dog. In this video, I'm going to present you the Shadow World plugin that I've developed and that is now available on the marketplace. It's currently available for 4.26, 4.27, and if you check the actual GitHub, you can find the Unreal Engine 5 version of the plugin. So what this plugin is doing is actually it's a tool to generate worlds extremely fast from the material shader in Unreal Engine. So what it's doing exactly, I'm going to show you here. I'm just created a brand new world and I dropped this Shadow World BP. And if I go to the folder in which this BP is sitting, I can find M-Define Winter material folder, which is actually the material folder generating currently the landscape. So as an input, I have the world position. From this world position, I've taken the G component, which is actually the Y coordinates, which I divided by 1,000, meaning 10 meters, and I've applied the sinusoid to it. The output has been divided by 1,002, and I've added an offset and linked it to the output of the material function. So right now it's generating a sinusoidal terrain, and I can, for instance, add time here. Okay, so right now if it's moving, it's actually moving way too slow, so I'm gonna add the time after dividing by 1,000. Okay, here you go. Okay, so right now the terrain is actually applying a sinusoidal offset by the time. So if I go into wireframe mode, you actually can see two wireframes. You have one dynamically moving, representing the waves, and you have a blue wireframe, which is actually static. The blue wireframe is representing the collision of the terrain, and the collision aren't updating at runtime. So the way it's working right now is if the terrain is moving, it's actually to depict, for instance, an ocean, and you're not generating collisions for ocean. So I can disable the collision here. So not only can you use a simple sinusoidal, you can also use, for instance, noise functions. So I've included in the plugin improve Perlin, fraction, Brownian motion, 2 times warped noise function, which is actually a noise function applied to itself multiple times, and it's currently generating this shape. Okay, we have to wait for the shadow to compile. Okay, so the terrain is currently generated in the material function, and you can see it's extremely fast and could extend to possibly an infinite world. Can apply another noise function. For instance, here I'm using the noise node from the material editor. Okay, so it's generating some form of mountains. And check this one. Okay, it's a set of mountains. So right now I'm currently using the runtime workflow for the world generation. So the terrain is actually computed each frame. I have the option to toggle the caching option, so the terrain is only going to be computed once when I'm moving the camera. And here you can see that I've picked an asset from the marketplace, which is named the winter foliage set, a winter set. There's a bunch of vegetation and assets that I'm spawning currently on the world. And it's all spawned runtime. So I could have used this actual asset on the sinusoid at the beginning of the video. So I'm changing the material function, and I'm gonna refresh the world, which is now using the cache system, so it won't actually update right now. I have to force the system to update the world. And here you can see actually the sinusoid of a material function. Oh, there's still time applying. Okay, I remove the time. Okay, so right now you have the runtime version, and you have the cached version with the biome applied to it using the asset from the marketplace. So it's actually spawning all the items really fast around the camera. And if I connect the more complex noise here, and force a rebuild. Okay, so I'm going to disable the caching. I'm going to use this material function to play with scaling of the world positions. It's a fast way to iterate on different shape with instant feedback. Okay, so I like this part. I'm gonna check how it looks from the cache version. Okay, cool. So yeah, here I generated a brand new world. It's fully playable. If I can pick, can bring a player start here. Okay, so what's happening is actually I may be too far away. Which distance am I? It should be fine. Okay, maybe way too far from the world origin. So I'm just gonna spawn here. Okay, here we go. Oh, I forgot one thing of importance. Enabling the collision. This is a collision in the blue mesh below. Here it is. Much better. Seems to find my buddy here. I'm gonna cheat a bit. Here it is. Here we go. Okay, so this is a sample using the winter pack from the marketplace. Now I'm going to show you the actual demo map from the project. So once you downloaded the plugin from the marketplace and enabled it in your game engine, in Unreal Engine, you can find it in the other Shadow World plugin. You have to enable the engine content and plugin content, and scroll down to Shadow World content. Here we can find a couple of demo maps. So I'm going to start with the map Ocean. So what you can see in this map right now is actually the dual usage of the landscape of the system. So both for generating a landscape and an ocean. And as you can see right now, I've made the two systems speak to each other. So the actual ocean can read the data from the landscape and generate a smooth transition to the towards the shore. So if I disable the reference, you can actually see the ocean only during where it's actually at the higher altitudes and the landscape below. So right now the ocean is actually updating at runtime. Of course there's no collision for the ocean, but there's collision for the landscape, and you can see the collision updating below and generating some grass. So to set up the system, I've picked the landscape and added a dependency, which is a data receiver. So the landscape is going to send data to the data receiver, which is currently the ocean. The ocean is another world with a data source set to data reference. And what it means right now is that if I go to the material of the landscape of the ocean, so the ocean is currently running at runtime, so it's using the runtime material. This is the material currently used for the ocean, and you can see it's currently reading the data from the landscape. So it relies on the landscape using the cache system. If it's computing and runtime the height of the terrain, it's not generating any height map, any normal maps, which allow to speed up the computation and only compute once. But if it's using actually the cache system, it's generating a height map and a normal map, which you are then able to share with the ocean. So the ocean is currently getting the cache maps, the height maps and the normal maps of the landscape. Then I'm going to go to the map 8 map. So what this map is actually showing is a couple things. It's currently generating a terrain not only from a noise function, but it's actually reading 8 map, traditional 8 map that I've picked from the internet, which is a 8 map from satellite picture. You can see it's not actually tiling, so there's a gap issue here where the map is ending. So the map is currently using is this one. So is it actually the way to see it? Yeah, but is it? We're around here. So if you check the generation of the terrain, you can the undefined function. You can see that I'm picking the 8 map, and I'm running it using a big material functions that I've put into the plugin. On top of it, I did a small noise, just because you want to add some finer detail to the map, so the small scale variation actually from the noise and not from the 8 map. Because the map is not of infinite resolution, you have some limits to what you're showcasing, so I've added a bit of noise to make it more interesting. And as you can see, right now I'm using the runtime raw flow. I disabled the caching. If I enable back the caching, I have some weird colors. Those weird colors are actually data layers that I've generated. So to generate data layers, I've added simple data layers here into the detail panel of the world. And I'm generating currently 2 layers. The first layer is named simple layer, and it's using this material function, this actually material, to generate its layer. So it's the material it's using right now can access the 8 map and the normal map of the terrain. So it's actually relying on the cache system to be enabled, otherwise you don't generate any 8 map, any normal map. So the first layer can access the 8 map and the normal map. The second layer can access the 8 map and the normal map and the first layer. So the more you add layers, the more the bottom, the last layer to be computed can access all the 8 map and layers that have been computed before it. So right now from this simple layer, I'm using this node to read the world position as a world normal. I'm getting the B component, which is actually the Z component of the normal, which indicates the slope of the terrain. And I've just added 2 filters depending on the slope of the terrain to generate the red channel, green channel. And for the blue channel, I'm using this texture, which is a noise from the engine. Okay, so what it's doing right now, if the Z component is higher than 0.9, which means the terrain is relatively flat, so the slope is limited, because the Z component is really high, so it means that I'm pointing towards the sky. If I'm pointing towards the sky, I'm gonna output a 1, so, and I'm gonna read these textures and fill the blue channel. Okay. I added another filter. Okay, so it's a filter on the noise rate by the product of this those 2 nodes. Okay. So once I've generated the data layer, I can use it in the cached material. In the cached material, you can see that you have access to the simple layer. And right now, I'm reading the simple layer, the RGB channel, and I'm displaying it as a base color of the map, of the landscape. So you can really see the when the slope of the terrain is important, which means the Z component is lower than 0.6. I'm filling the red channel, which is actually what you can see here. Otherwise, I'm reading these noise textures and filling the green and blue channel. Okay. Once I've generated this layer, what I can do with it is either use it in the material editor to blend between materials. So I can choose to have different materials where these different colors are, or I can choose to spawn assets where there's different using the data layers. So for instance, I've added a grass spawnables, which is an instant static mesh, and I've added a custom material which is going to define where the instances of the grass are actually spawning. This material is going to read the simple layer, green channel, And if the green channel is higher than 0.1, it's going to return 1, otherwise return 0, and feed the filter output, the filter input of this custom node here. So what it's going to do is, if the green channel is higher than 0.1, it's actually going to spawn grass, a grass element. Otherwise, it's not going to spawn any grass. And you can see it if I'm going close to the terrain right now. It's spawning grass, whereas the green channel is. And the green channel is higher than 0.1. It's actually exactly like a landscape material where you will define the foliage spawning in the material. So not only can you spawn instant static mesh, you can spawn actors too. So I've created small demo actors, which is called BP to spawn. It's really simple. What it's doing right now is displaying a text, which is hello, I'm an actor. And if you get closer to this actor from a given range of 2.5 meters, it's gonna play a sound, it's gonna emit a particle, it's gonna hide the text, and then it's gonna destroy itself after 2 seconds. So we can try it. Okay, so I'm still in multiplayer. Need to disable it. Okay, I'm getting middle terrain. Here I can find one of the actors I spawned. Okay, it's playing sound and it's destroying itself. Okay, so what we've seen on this map is reading an 8 map, generating a data layers, and using this data layer to spawn an asset at a specific location on the map. And we've now realized that we can spawn both instant static mesh and generic actors. Okay, moving on, we're gonna see the reference demo map. This new map is going to showcase another tool set to more precisely define your world. So right now I've just used a simple noise to generate the world. Okay, so it's actually the same noise that was used to generate the landscape, which was featured in the ocean map. So you can see the performance on grade because I'm most likely generating collisions at runtime, and I can't move really fast. If I want to move faster, I'm going to disable collision. Okay, here we go. So now I can move extremely fast. Okay, back to here. I'm gonna enable the collision back. Once I enable the collision, the landscape is gonna know precisely the position of the camera compared to the ground. So it's gonna be able to adjust its LODs accordingly, and it's gonna spawn any vegetation which can be spawned on a given LOD. Because right now, to spawn an asset on the ground, you get to define a range to spawn it, and the spawnables are actually reading the current LODs to check that you are at a given altitude, that you can see at a given distance with a given precision to spawn itself. So the spawning of elements is actually tied to the LOD visible. Is what I mean. So another cool tool you can see on this map is actually the use of a brush system. So if you select the world, you can see that I've added a brush manager, which is just a simple asset that I've dropped in the world. This brush manager is actually managing a layer stack, which is gonna add itself after the generation of the original 8 map. So I'm generating this landscape using the material function, and after that I'm sending the 8 map to the brush layers, to the brush manager, which is gonna add the relevant brushes to the terrain if necessary. So the brush have boundaries. You can see a box right now, and if if the LOD I'm currently generating do not reach these boundaries, it's not gonna compute this brush system. So it's a simple way to optimize the performance of the brush system. If the LOD I'm currently generating is too far away from this brush, it's not gonna compute. It's not gonna process this brush. So you have to check that the boundaries of your brush are actually proper. Otherwise, you might skip the computation of a brush. So the brush can edit the terrain at runtime. So, going back. So here I'm editing the terrain at runtime. What it's doing right now is that it's reading the 8 of the brush and blending between the actual map, the actual 8 of the terrain, and the 8 of the brush. I've added a radius system, so if I pick this one, for instance, which is the brush 3, and increase its radius, you can see it's actually moving the terrain around. So exactly what I was saying earlier, you can see the boundaries of the brush, and you can see the zone, the area of effect of the brush, which is much larger than the current boundaries. So the current LOD at the bottom of the screen are not processing the brush system because it's believing that it's not impacted by the brush. So I have to increase actually the brush boundaries. Here we go. Okay. Okay, so I've increased the brush boundaries, but it didn't update the vegetation, the spawnables. So I'm gonna force an update of the spawnables by checking this box here. We built vegetation only. Here we go. Okay, so now I have a terrain. I can bring. Should be able to spawn here. I'm gonna change the game mode to the third-person game mode. Okay, so where is placed the player start right now? Okay, I'm gonna place it here. Here we go. So if I check right now in wireframe mode, I can see the collision mesh and of this brush. And I actually can edit it at runtime. So you can see the collision mesh is actually moving. There's a bit of a delay because it's actually there's a delay for the collision generation. The collision are actually changing at runtime too. So there's a better way to improve the performance of editing at runtime the terrain. But right now, the only way to edit it is through the brush system and the current brushes available. You can create your own brush. A brush is actually just managing a dynamic material which is going to be applied to the 8 map generated. So right now I'm grabbing the current height map, the altitude of the point, the altitude of the brush. I'm checking the difference, and if I'm closer than the influence radius, the closer I am to the position of the brush, the more I'm going to blend towards the altitude of the brush. It's using a simple square blending. I could have used an exponential, could have used, there's a lot of options. And those parameters, the influence radius and the invert parameters, are both set up from blueprints. So there's no C++ involved. You can create your own brushes in Blueprint, in the shadow editor. You don't have to dive at all in the C++. You create just a shadow world brush. You add it to the stack of Brush Manager, and you can do whatever you want after. You can play with the influence of a given brush, of a given layer. Where is this brush demo? Okay, this one. And the large one is the brush tree. Oh, the brush tree. Which one is it? Oh, this one. Here we go. Okay, so that's it for the presentation of the Shadow World. There's a simple documentation linked in the on the store. You can reach it through this link. And I did a Discord link. I just literally created it a couple of hours ago, so it's pretty basic. But if you have any questions, any tips, any remarks, if you encounter any issues, just reach out to me into the Discord, and we'll figure it out. Thanks.